Hi everyone, my name is Alex. I'm here with Irfan. Irfan, do you want to say hi?
Hi Alex, hi everyone. I hope you're doing very well.
Excellent. All right, today we have the super fun section of 1.5 where we're going to bring everything together. This is the last section for chapter 1, and we're going to practice everything that we have learned in one section. Are you ready?
I'm perfectly ready. Let's go.
Excellent. Okay, before we get started, let's talk about what we learned in the last section. Irfan, do you remember what we learned in section 4?
Of course, we learned how to develop class methods systematically
Mm-hmm.
by using method parameters and testing. We learned about the design recipe as well, which has 5 steps: purpose question, signature, example, coding, and testing.
Mm-hmm.
And we did some of examples.
Yes, exactly. And if you remember from the homework session that we had in the previous video, we learned about testing in IDEs and what is the right way of testing your method instead of just printing whatever result you want to get.
Exactly.
Excellent. All right, so let's begin. Okay, so you have learned how to represent information as data. Um, and if you have a complex information system, you know that, oh, whoops. Okay. Um, you know that you need something like classes.
Right.
Yes. We also learned how to represent different data types. We learned to represent numbers as double. We learned about ints. We learned about strings. And if you remember, we also learned about booleans in a homework as well.
Yes.
Excellent. Let's talk about trees. Are you ready about trees? This
I'm
is
pretty
my.
excited about trees.
I'm very excited about trees. I'm like an awful artist, so I'm gonna label this as a tree so that you know it's a tree. Okay.
Okay.
Trees are quite cool. So from the diameter of the tree, you can actually get how much water they need. So if you take a tree and they have a circular base essentially, this is their radius, this is their diameter. And from that, you can actually calculate how long you need to water them. And every tree has something called a growth factor. And uh, a growth factor helps us understand, um, a tree's size with its age. So all you need to do is multiply a tree's growth factor by its diameter, and then you will know its age in years.
That's actually very cool.
That's pretty cool, I agree. So, as a general rule, you can multiply a tree's diameter by 5. That's like a typical, I guess, growth factor. And you can determine this number. Um, sorry. Okay. Um, and just so we shouldn't cut down a tree to figure out its diameter. You can figure out its diameter from the circumference as well, as you know. So if you have a circle and you know the circumference, you can also just get its diameter. So you don't need to cut down the tree and, measure the diameter. Does that make sense?
Right, yes, it makes sense.
Okay, excellent. So imagine you have an amazing garden and you have a lot of trees and you need to, water them for some reason. You've decided gardening is your life goal. Woo. So we want to write a program to automate this process. Are you ready?
Yes, let's go.
Excellent. Okay, so once again, we have information and we want to represent it as data. The first bit of information that we have is actually trees. So we need to represent trees. How would we represent trees?
We would first create a class tree for it.
Yes, exactly. Trees are too complex for a string or a number. So we would have class tree. Okay. What information should it have?
So as it said already, there's going to have a growth factor, which is an int.
Right. The growth factor is going to be a whole number, so it can just be a int. Okay.
And then, for example, the name and kind of the tree. So it's going to be a string.
Yes, exactly. It's going to be string, the kind of the tree, because that will help us figure out a lot of other information as well. Great.
Exactly.
Um, so the circumference, though, we also care about that. How should we represent that?
How do we represent the circumference?
Should we add it as a field?
We can add a radius and maybe its diameter.
So here's the problem with adding the radius or circumference or diameter. If you take a look at these two fields that we have, they're very consistent. You know, a tree is not going to change its kind. You're not going to start with an apple tree and then some years pass and then it becomes an orange tree. That's just not going to change. And the growth factor, for the most part, is also going to be the same. If a tree's growth factor is 5, it's going to stay 5 for the most part. However, the diameter or the radius or the circumference changes a lot throughout time, right? Every week that you water your tree, it might get bigger and bigger. So we probably will avoid including that in our fields because the fields should be more about the properties that are going to stay the same for a long period of time. Does that make sense?
Yes, it makes sense. So what are we going to do?
Well, this is excellent. For now, we're just going to leave the radius out of the tree's field and we can represent it in different ways. But we know if we want to make a new example of a tree, what should the class have?
It's going to have a growth factor and a kind.
Right. But it requires a constructor, right? We need to construct, we need a way
Oh, yes.
to construct a new tree. So we can say create a new tree. And then how do I write a constructor?
So its name is tree, then parentheses.
Okay. Can you already notice a mistake I'm making?
Yes, it's not capitalized.
Exactly. And we know the constructor needs to match the class name, and the class name is also not capitalized. So we need to make sure that we go with the convention and have capital letters for classes. So it's going to be capital T tree. All right. What should it take?
It will take the int growth factor
Mm-hmm.
and then string kind.
String kind. Yes, exactly. All right. What should I have in there?
This dot kind gets kind. And then these dot growth factors gets growth factor.
Yes,
Obviously.
exactly. It's probably better to have it the other way around so that you follow the same um,
Oh
order,
yes.
but it doesn't matter for this case because you're explicitly saying this growth factor field should get the growth factor int that you're passing in. Excellent. All right, so we have our constructor.
Now we need to design a method to determine how much is the age of the tree, right?
Yes, let's start with the tree's age. All right, how do we design this method systematically?
We'll start with the purpose statement.
Excellent. So purpose statement is a comment, so I'll start with the 2 backslashes. All right.
What is the age of this tree?
Yes, perfect. What is the age of this specific tree? This tree, probably in years, right?
Yes, exactly.
Excellent. All right. So, um, where should this method be?
It's going to be in the tree class.
Exactly. Since we're going to say this tree, that already tells us, well, it should be in the tree class because it's about information about the tree. All right. So then we want to have the signature of our method. So what's its input and output?
So its its output is going to be a int number, I think, because it's age.
Okay.
And then our name is going to be get age, for example.
Yep.
Then our input is the circumference that we have.
Exactly. And what is the type of circumference? What?
It could be also a decimal number, so we would put it at double.
Excellent. So if you have, sorry, let me just write this circumference. If you have the circumference as a decimal and you're going to do some calculations with it, probably with the diameter and the growth factor, what would the output type be likely?
You're right, it might also be a decimal number, so it's better to be a double.
Exactly, yes. Even though age in years makes sense for it to be a full whole numbers, but it's possible that we're going to say the tree is going to be 3.5 years old because of the circumference. Unless we want to limit the circumference to be a whole number as well, in which case we can have both. All right, what's the next step?
So the next step is to have an example.
Excellent. Let's go for an example. All right. Do you have an example in mind?
For example, we could imagine that a tree's circumference is going to be, let's say, 80 cubic centimeters, metric centimeters.
You mean 80 centimeters?
Yes.
Okay, do you want to restate that sentence? Okay. What's an example?
So an example is a tree's circumference. Let's say it's 80 centimeters.
Okay, 80 centimeters for its circumference. Okay.
And then we would have to calculate its age.
Okay. Let's say it's like an apple tree because we need to know its kind as well.
Right, yes.
Here's the problem I have though. You're giving an example with information that a tree doesn't have necessarily. So if we look back to the tree example, to the tree class, it should have a growth factor and it should have a kind. So in your example, we should have an example tree. And then an example tree would have kind, it's an apple tree, and let's say a growth factor of 6. Does that make sense?
Okay.
Okay.
Yes, it makes sense.
So first you need to measure its circumference. And then you can get the diameter. And how do you get the diameter from a circumference?
You will divide the circumference by pi.
Yes, exactly. So you divide circumference by pi, you get the diameter. And then we can calculate it. We can calculate the age by saying diameter multiplied by the growth factor. Does that make sense?
Yes, it makes sense. But how are we going to represent them? Because we don't have this information in the constructor.
So the constructor, this is a great question. The constructor only cares about information that are true about a tree always, okay? So we will have the information that's true about the tree in here. And then this specific method, which is get age, also asks for an additional thing, which is circumference. So let me just give you another example. Let me walk you through another example. So I will make a tree called orange tree. Okay. And it will be a new tree that has a growth factor of 5 and type orange. Okay?
Okay.
So far, so good. Then I want to say orange tree dot get age. So I'm calling this method get age on it. And at this point in time, its circumference is 80 centimeters. Okay? I expect this to give me age in years.
Now I get it. It makes sense.
Right? So the reason why we have divided this information to 2 is because this information is always true about this tree. This, however, can change. So I can call this method when the tree is only 80 centimeters. I can call it when it's 100 centimeters, and so forth. But it will always be an orange tree, and its growth factor will always be 5. Does this make sense?
Exactly. Yes, it makes sense.
Okay. So if I tell you an orange tree has a growth factor of 5 and its current circumference is 80, how would you calculate its age? So first you need to get its diameter. So you would say diameter is 80 divided by pi.
Right.
And then whatever you get from that, you would say 80 divided by pi. You would multiply all of that with the growth factor, so 5. And then that's the age, right?
Right, yes.
Excellent. Okay, now that we've walked through the example, we know exactly what our code needs to do. The coding part should go pretty easily. So again, we have the purpose statement. We had the signature, which was double, get age, and we had double the circumference, And imagine there's like a brace over there and then there's a brace over here. All right. Now, step 4 of the design recipe, I need to actually code. What should I start with?
So first we need the diameter. So
Mm-hmm.
we will start with it by a double number.
Yes, exactly.
Double diameter gets, we know it's circumference divided by the pi.
Pi is typically a number that's defined in most IDEs, but there are libraries that you can access to give the exact number. Well, not the exact number, obviously, but to a good approximation of pi. So I'm just going to write it here as pi, but you can figure out how to uh, write that in your program. And then cir is just my shorthand for circumference from the parameter. All right, so we have the diameter. Great. What's next?
Yes. So we want it to return the diameter and multiply it by the growth factor.
Fantastic. So return diameter, multiply it by, how do I write this?
That's growth factor because we already have this information.
Fantastic. Whoops. This dot growth factor. That's exactly right. Does this all
Perfect.
make sense?
Yes, it all makes sense.
Perfect. We can also just change pi to just be 3.14 for the sake of our example, and we can go from there. All right. Should we move on to our next method?
I think we didn't do the testing yet.
Excellent. Yes, the testing part is the super important part. So let's do a test. So we expect, um, remember we have the tree class already. We have this example tree. So let's say the orange tree already exists with growth factor 5 and kind orange. All right, we expect the orange tree dot get age when it has a circumference of, let's say, 30 to return, well, it's going to return 30 divided by 3.14, all multiplied by 5. Um, with a margin of 0.001. Because it's a double, so division and multiplication after division mostly can create some errors or a margin of error.
Right, exactly.
All right, does this all make sense?
Yes, perfectly makes sense.
Excellent. Okay, so we now know the age of our tree. What we want to also say is how long we should water a tree. So again, we want to go through our design step and design recipe. So what's the first thing that we would do for writing our method?
The purpose statement.
Mm-hmm. Excellent. And
So we want to know how long to water it. So the unit is going to be a minute.
exactly.
How many minutes does it take to water this tree?
Perfect. Yes, we want to make sure we can be as precise as possible when we're writing our comments or purpose statements. So how many minutes makes perfect sense. To take to water this tree. Excellent. All right, what's the next step?
The signature, it's going to be a time, and it might be a decimal number, right?
Yeah, it could be a minute and a half, so it will be a double. Yes.
And then we can choose a name for it, like get watering time.
Mm-hmm.
And then the input, which is double circumference.
Yes, exactly. Oopsie. Um, yes, precisely. So we know that the input is going to be the circumference because that's the only thing that changes about the tree. Everything else exists in the field. And then the output is going to be another number that's going to be a double. Fantastic. All right. So, what's the next step that we should go with?
What is actually the next step?
So, we need to give an example of this, right?
Right, yes.
Yes, okay. So, let me just write this. Okay. So, let's say our orange tree, let's say it had a growth factor of 6, um, and it has a circumference of 30
Okay.
at this current time. Um, we expect it because پنجاه کجا میاره؟
آفرین آفرین
فکر کنم 50 از قبل میارم. برای همینه که 6 رو گروه فکتور کردم. آره اما اولش گفتم که watering time رو you can calculate for how many minutes you should water a tree using its diameter. You can multiply the diameter by 5 to determine this number.
نوشته بودی؟
آره اینو اولش نوشته بودم. آره. Okay, let's go.
Okay, I know, makes sense.
Okay. So we have the orange tree, and it has a growth factor of 6 and the circumference of 30. We said at the beginning, if you remember, as a general rule, you can multiply the diameter of a tree by 5. 5 is just like a general rule of thumb that gardeners can use, and we can get how many minutes essentially it needs to be watered. But remember, the diameter, one thing we didn't talk about, it's the unit of diameter. It needs to be in inches for these formulas to work. So we have to make sure that the circumference and the diameter and everything are in inches. Does that make sense?
Yes, it makes sense.
Okay, excellent. And we've already discussed about how to get the diameter, so we can just do that again. So
Exactly.
excellent. So let's go with well, actually, it's already existing here. So double get watering time, and it takes in a circumference. How should we proceed with the code?
We'll have to get the diameter. So it's, again, double diameter gets circumference divided by 3.14.
Yes.
And then return the diameter and multiply it by the growth factor.
Not by the growth factor anymore. We're gonna return it. We're gonna multiply it by 5, the magical number, right?
Yes, right.
Yes. So in this method, we actually don't need any information about the tree. So it doesn't matter that it's an orange tree. It doesn't matter that it has a growth factor of 6. All it matters is that the circumference is 30, and we're going to multiply its diameter by 5. Great. Are we done?
We didn't do the testing yet.
Good job. Excellent. Okay, so for this example, we can just convert that to a test, and we would say we expect orange tree dot um, get watering time to return. So it has a diameter of 30. So it would be 30 divided by 30.14 multiplied by
5.
excellent, with a margin error of 0.001. Does this all make sense?
It all makes perfectly sense.
Excellent, I'm glad. All right, are you ready for your favorite part?
Absolutely. Let's see.
Yay, homework. Woohoo. Okay, I'm going to give you a few homework problems, and they're going to super impress your parents. Yay, parents. Okay.
Of course.
All right. So the first problem I have is that imagine that you're in year 2030, so not that long from now, and books can now read themselves to kids. So parents don't need to read books to kids anymore. You want to design a story reader that is basically a story reader script that will start with a greeting. So we'll say something like, "Hi, Irfan," or "Hi, Alex," or whoever it's reading to. Start with a greeting, and it follows obviously with the child's name. So, after saying hi, it says Irfan or Alex, and then it goes on to read the content of the story or the book, essentially.
So we need to design a story reader.
Exactly. And I want to see a read method in the class, I assume, that you will decide to design, which just returns the script as a string. So
Okay.
this is a fairly simple exercise. Shouldn't take too long. But yeah, it will be quite a big hit with all the parents. Does this make sense?
Yes, it all makes sense.
Excellent. The second problem I have is different. So when pipes, you know what pipes are?
Yes, I think.
Yes, actually. So when pipes are, in people's homes, when they burst, it is an absolute mess. It makes a huge mess, and people hate it. But we can change it. We can make it a fun mess. So we're going to decide to replace pipes with hollow cake cylinders. It's going to be fantastic. And when they burst, you can have cake.
Wow, that's impressive.
It's going to be great. So I want a data representation of these pipes, essentially the cake cylinder pipes. And I want them to also include how much water they're going to have. Because essentially, there will still be pipes, they will still have water inside of them, but they'll just now be made out of cake.
Right.
Excellent. Any questions on this?
No, no questions so far.
Fantastic. All right. Have a great day, Irfan.
You too.
Bye.
Bye.